Assalamu alaikum students. Welcome back to my channel. In last video we saw till question number 12 or 11. Now today we are going to solve problem number 13 of chapter number 25 from Halliday, Resnick, Walker, Fundamentals of Physics. The video is only for the educational purpose. The question is, a 100 picofarad capacitor is charged to a potential difference of 50 volt. Original potential given is 50 volt and the capacitance is 100 picofarad, and then charging battery is disconnected. After that the battery is disconnected and capacitor is then connected in parallel with a second capacitor which is initially uncharged. So the charge from the charged capacitor will transfer to the uncharged capacitor until they reach at the same potential difference because they are in parallel. If the potential difference across the first capacitor drops to 35 volt, then what is the capacitance of the second capacitor? The second capacitor capacitance we have to find. So let's solve it. Very easy question. I've solved this question for you. The given data is V1 initially is 50 volt and C1 is 100 picofarad. When this a capacitor of 100 picofarad is provided a potential difference of 50 volt, then the fully charged capacitor will have a charge is equal to Q is equal to CV, and that will be equal to C is given as 100 into 10 raised to minus 12 because 100 picofarad, pico means 10 to the minus 12, and V is this is C, and V is potential difference which is 50. We multiply it. When multiplied, it comes out to be 5000 into 10 raised to minus 12 coulombs because we are using in SI units. The SI unit of charge is coulomb. So Q is equal to if you make it 5, then we have to add power 3 here because we have to 5000 means 5 into 10 power 3. So 10 power 3 is added here. So minus 12 plus 3 is minus 9. So we get 5 into 10 to minus 9 coulomb, or we can write it 5 nano coulomb. This is the charge on a fully charged capacitor. Now this battery is removed and this capacitor is connected in parallel to another capacitor which is initially uncharged. So after when the battery is removed and a capacitor is connected with another uncharged capacitor, then the potential on this capacitor C1, which is initial capacitor, drops to 35 volt. Now both capacitors are in parallel, therefore they will both have the same potential difference of 35 volt. So Q dash on this capacitor, first capacitor which is initially charged, is equal to CV dash V1 dash. V1 dash is the 35 volt. This is the new charge on the capacitor when the potential difference across it drops to 35 volt. So Q1 dash is equal to 100 into 10 to the minus 12 into 35 because 35 is V. So by multiplied we get 3500 into 10 to the minus 12. Same argument here. When we can write it 3.5 into 10 to the power 3, 3500 is 3.5 into 1000. 1000 is 10 to the power 3. 10 power 3 is added here. Minus 12 plus 3 is minus 9. So we get 3.5 into 10 to the minus 9. Minus 9 is nano. So now new charge on the capacitor is 3.5 in nano coulomb. Okay. So because they are connected in parallel, therefore charge on the second capacitor will be equal to, original charge was 5. This is total charge. This charge is left on the first capacitor, so the remaining charge has been transferred to the second capacitor. So charge on the second capacitor will be equal to 5 nano coulomb minus 3.5 nano coulomb because the initial charge, this is final charge. So the remaining charge is lost for the first capacitor, that will be transferred to capacitor 2 according to law of conservation of charges. and also this is parallel capacitors, so their sum of charge will equal total charge. So Q2 is equal to 5 nanocoulomb minus 3.5 coulomb, so 3. When we multiply subtract it, so charge on second capacitor, which was initially uncharged, is equal to 1.5 nanocoulomb. So we have to find the put capacitance of second capacitor. Now we know Q2, we know V2 also, because they are in parallel, so V2 will also be equal to V1 dash is equal to 35 volt. So we write, since the capacitors are in parallel, therefore V2 is equal to V1 dash is equal to 35 volt. So we can use Q is equal to CV, or C is equal to Q over V. So C2 will be equal to Q2 over V2. We know Q2 is equal to 1.5 nanocoulomb, nanometer 10 to the power minus 9. So right, 1.5 in 10 to the power 9 coulomb over V2 is 35 volt. We solve it. This 1.5 can be written as 1500 into 10 is to minus 3, or we can write it minus 3 minus 9 is minus 12. You can change it, because if I want to make it pico, I want here minus 3. So minus 3 means we have to multiply this with 1000. 1001 multiplied with 1000, it becomes 1500. So 1500 to minus 12 over 35. You can use calculator directly also. So when we solve it, I have done without calculator. So 1500 over 35 or 300 over 7 will become 42.85 in 10 minus 12 farad. Minus 12 is pico. So answer is the capacitance of the second capacitor will be equal to 42.85 picofarad, which can be rounded off to 43 picofarad, and that's the answer of the question. So the capacitance of the second capacitor, which was initially uncharged, is 43 picofarad. So that's it. I hope you like my video. If you have any query, you can ask me in comments. If you are new to my channel, you should please subscribe and press the bell icon, so that you can get all the notification of my coming videos. See you in next video very soon. Until then, Allah Hafiz, take care, bye.